So, Chair, I'm going to call you up here one. Yes, from PDF.
I just picked up
The little things that are in the PDF.
what? I have no idea what we're calling it. Okay.
No, I upload the PowerPoint and the server converts it.
No, it doesn't.
That's true. It does it over time.
And I know media for a couple of dollars.
Yeah.
Here, you can see. You don't think it's bad. Yeah. You never recall the way.
Okay, we're going to try and get started here as we do trial and error learning of this Chromebook. So, note well, please. By Thursday, you should have read this like so many times. So I'm not going to go through it, but please honor it. So we were just rechartered 5 days ago, and 4 new work items were added as part of that recharter. So there's a call for adoption for each of those 4. At this point, about half of the people are speaking for and against one of the documents, and everyone who's spoken on the other 3 has been supportive. We'll make a call on that shortly. And this is the charter that we had discussed on the mail list. So far as I know, there are no bashes, but if there are, please go to the mic now. Okay, then we're going to follow this agenda for today. I will point out that in agenda item 4, of the 4 documents that we're considering for calling, 3 of them have my name on them. So for those 3 items, Tim will be making the consensus calls, not myself. Okay. Now we need to figure out how to get to the CAA slides. And while we're doing that, Jim's going to talk to you about the 5750 and 5751 document.
I may have my numbers backwards. 5750 is past the IESG and is waiting for the area director to verify that I have made all of the edits required by the IESG and then release it to the RC editors queue. 5751, last time I looked, still has the discuss on it. Ben has not cleared it. The IESG objected to the fact that I said that a decision that we made was due to politics. Yes. And that the paragraph in question has been removed and a new version has been published. So as soon as he clears that discuss, it will go to the area director to check that I've made all of the edits, and then will be released to the RC editors queue.
So the other one, Erica's, or are you just trying to send them as a pair because they're going to sit in the RFC editor queue anyway? Okay. All right. All right. Let's see how this presentation thing works. Philip, you want to come up?
Yeah.
Yeah, I underestimated the time it would take me to get here. Okay, so this is mostly Jacob's work because. Can I have the next slide? This is not.
This is not.
Is it? Okay, so there's a new draft that is now entered as a working group draft. And if you skim through to section 8, there is a differences section, which is kind of, useful. And I'm taking it on faith that there's no other changes in there. I've not, so basically we're obsoleting RFC 6844, modifying the key climbing algorithm, which was the main semantic change that we needed to make. And this has to do with basically, well, the world has changed since we originally wrote CAA, and what had been a corner case is now the dominant case and vice versa. So it simplifies the processing algorithm. So it's only performing tree climbing on the domains in the chain. It's not going elsewhere. And the only time it's resolving C names is at the resolver for the things that are actually in the chain. There's a deployments consideration that's been added, which is now based on experience. And there's a clarification of the ABNF grammar and clarifying issues like, what happens if you have a CAA record, but there isn't an issue or an issue wild record, and all these corner cases that people have come up with and chose to decide that there was ambiguity. I mean, I don't think that we've actually changed anything semantically, but we have removed the ability to claim there was ambiguity. Okay, so next slide. There's a few things outstanding on the list. One thing that we've not fully closed on, when CAA was first proposed, it did actually have a policy tag. So it allowed you to say, this domain only has extended validation certs issued for it. That was removed. And the reason for that is if you have a record that says you can only issue certificates from Alice CA for this domain, well, anything beyond that can be agreed out of band between the subject and Alice CA. And that's better than trying to put every piece that you might want to put in that conversation into the CAA record, or at least that was our feeling. So that's what we have said on the list, and if anybody's got any disagreement with that, please say so on the list pretty soon, because I'd like to mark that closed. Finally, there was an issue raised the other day with the ABNF again, and a tweak to it, which looks like it's right, but somebody's got to put it through the ABNF checker. So if you go to the last slide. So there is one other issue outstanding, and this is one of the questions that have come up about what to do to report errors. And this is something that came up in another working group and has started popping up all over the place. And it looks like we need to have some way of reporting stuff that is generic across, if we're going to change the way that it's done in CAA, I would prefer to do it in a way that is replicable by other working groups. And there is a proposal to do that based on some work that Dave Crocker has done on cleaning up the prefixes in DNS. And so we've got to see what's happening with that draft before you write a new text around it. So that's an action item on me to talk to the ADs concerned to find out if they're progressing Dave's drafts. So, questions?
Your Honor, there's a lot of noise in ACME about parameter syntax in 6844, and either you didn't mention it or you alluded to it and I missed it.
The parameter. That's the A, B, and F stuff.
Okay.
Yeah. Yeah, I mean, there were two issues. One, that some folk wanted to put dashes in the tags, and I didn't allow for that originally.
That Rich Saul's Acme. So the plan that we came up with in the working group was we're going to submit an errata to the original doc that will basically map the white space mapping to what this one is, because we don't want to wait on our extension draft, on our CAA usage, our CAA challenge draft for this to go through the cycle. So we're just going to submit errata. It's going to be AD approved, and then the two will be compliant in the white space area. That's all.
Okay, so that's basically what we've done with the other tree climbing errata.
Corey Bonnell,
Why
Trustwave.
did that take like 50 messages?
Well, I think this is one of the you know, as soon as you touch the DNS, it takes 50 messages. I mean, the thing that got me was that when we did the tree climbing one, I got 4 errata on the errata from the same person.
Corey Bonnell, Trustwave. So the ABNF actually, so if you look at it, it had an ambiguity based on the white space, but then also in section 3, and it specified that the parameter delimiter is a semicolon. So the document was actually just downright contradictory, and some CAs went off and used semicolons to fill in the parameters, and other ones used white space. So beyond that, I think the ACME CAA, the proposal there uses semicolons. So when I originally submitted the mostly corrected ABNF grammar to 64 piece earlier this year, I switched it to use semicolons there. And then Ilari Lewis Barra, sorry if I butchered the name, found a problem again with the ABNF, eluding basically multiple white space characters. So put the ABNF tools through their paces, and hopefully they'll be the last of the issue.
Okay, great. Yeah, the semicolons, I think, is the right way to do it, since that's the way that happens in all the RFC 822 type parsers have been using semicolons to parse headers since forever now. So that's the way to do it. And also, that's what DNS service discovery says to do. So I think that's the path. Okay.
Thank you. Quinn, you come up.
So, we've been adding the shakes to PKIX and CMS for signatures and hashing and MAC. Originally, we decided to use the hash parameter in the RSA PSS signature because that was the least amount of work we needed to do. But last time the group decided to use new OIDs and hard code all the hash, all the parameters, so that it would be very simple, no way for implementers to mess up, and that was a good idea. And with that direction, we basically rewrite the drafts to make it happen. So we right now I have two new OIDs for the RSA PSS, which hard codes the hash, the source, and the MFG function to generate the masking value in the document. We also updated the public key sections and with the new IDs and more description about the usage of the new OIDs. For the Bkix draft, we removed the shake hash function section because it's not needed anymore because we hard coded all the hash function in the digital signatures. And we do a lot of editorial fixes to make the draft read a lot nicer, shorter, and cleaner. So here are the OIDs. The first two ones are the OIDs for the RSA PSA with shake 128 and shake 256. And with this new OIDs, parameters are empty, absent, nothing there. The hash function is corresponding to the name indicated there. And the hash function used in the MFG function is the same with the hash function, which hashes messages. So there are no parameters are needed at all for the PSS OIDs. For the CMS, we have for hashing we have the shake OIDs themselves over there. And again, the length, output length for these functions are correspondingly 256 and 512 bits. And we have KMAC, which is used instead of HMAC. And also it carries no parameters at all. It's just one OID because we hard-coded everything in there. The S value is empty in this definition, and the output length is again 256 and 512. So there's no need for any parameters to go along with OIDs. So it's very clean. I think that would be pretty much it.
Okay, Quinn, I have a question.
Yes.
I noticed that the document has the missed arc for the OIDs to be assigned. That means they need to be assigned before it goes to the RFC editor. So when do you plan to do that?
I'm going to do it if the group is okay with what the structure of document and everything and accept it the way we define OIDs right now. Okay. Then I do it. I will request it to do it.
So I think the cleanest way to deal with that is to do working group last call. If it passes last call, you assign them, update it, then send it to the ISG.
How about this? I do it next time we get OIDs in, and then we call the last call after that.
Okay.
Because I think it will happen, but I'm not the everything ethnicist, so it's not good for me to.
I understand you don't want to sign them and then have us change. That's why I suggested let's do the working group last call. Then you can assign them however long that process takes. Then we'll send it to the ISG.
That would be perfect too.
Okay. Does anyone think this document is not ready for working group last call? All right, we'll start it next week.
Thank you.
Right. Okay, in London, this internet draft went to Sec Dispatch. Sec Dispatch sent it here, and the charter was done to allow a place for this. So I'll foreshadow the idea at the end. This is to make sure that you have the information you need to respond to the call for adoption. Next slide. So the CFRG has been working on digital signatures that are based on one-way hashes since 2013. One of those documents is Draft McGrew #SIGS 11, which has completed the last call within that research group. And it's based on the Leighton-McColity work that is in turn based on the Lamport, Diffie, I cannot say his name, Winternitz and Merkle. Basically uses Merkle hash trees to create signatures. It has the properties that it has small private keys and public keys, fast signatures generation, fast signature verification using a small amount of code where the hash function itself is actually the biggest part of that code, but it has very large signature values. And the key generation, it can be fairly slow. It depends on the size of the tree that you want to use. The interesting property, in addition to those, is that the hash-based signatures will remain secure even if the attacker does get a large-scale quantum computer. So it's like enough bits to my understanding is 2x the hash size. The quantum computer needs to have that number of qubits. Right. Next slide. Eric wants to expand on that. Go ahead.
No, I mean, maybe I'm confused. My understanding was Grover's algorithm got you square root more or less irrespective of the size of it. I mean, for practical size of a quantum computer. So, so like you just get incredibly huge to get like that. It must have been for that. I mean, that's my totally layman's understanding.
I should have turned to Tim for that. He understands this quantum stuff better than I do. Okay. Next slide. So I developed this internet draft. It's been being developed roughly along the same parallel course as Draft McGrew. And the idea is that how to apply those signatures in CMS. My motivation ties back to RC 4108, which is a specification on how to use CMS to protect firmware packages, where the small verification code size is attractive in many of these small devices that we're talking about for IoT. And the idea is if we can deploy a quantum resistant signature now, then if we ever need to deploy the rest of the quantum resistant cipher suites, we'll have a way to provide integrity protected firmware packages to implement those algorithms. That's why I care. Next. So the ask is that this working group adopt the draft. I would like review and comment. And as I said in the beginning, of course, Tim will be making any consensus calls related to this document. Questions? Cool. Next one. So we have a thread going on the mail list. I guess we could, I guess Tim could hold the hum to see if there's anyone in the room thought otherwise. Use the mic.
Hands on how many people have actually read it. Okay. I mean, we could do a quick hum on people's general feeling on the position of, you know, how do you feel about the current draft? if people would think that would be helpful. I think a lot of people haven't read it yet, but yeah, I was surprised as well. The draft's been around for a while because it went through Sec Dispatch, and I think probably a lot of people read it at that point before it got referred over. Yeah, yeah, exactly. No, I think it would be useful to see. So since it's not sort of an approval or not approval thing, let's go with option A. Is this is looking good. We need to discuss it and make some comments, but we think we should go forward with this. And let's go with option B. There are some more serious things that need to be reworked, and it's not just going to be a little bit of editing here and there. So just to get a little bit of a consensus on where we are. So option A. All right, and then option B. Okay, it sounds like everybody likes it. So, all right, thank you.
Oh, that's the draft.
Yeah. Yeah, yeah, that would be very helpful.
I tried figuring it out. Not that one.
No, he's
He's
yeah.
just making them up there.
Yeah, no, thank you very much.
Why did you show me that? All right, thank you. Okay, so the point of this document is also quantum resistance. Next page. So the idea is to use a pre-shared key in case some quantum computer comes to pass. The concern is that if we do get a large-scale quantum computer, that RSA, Diffie-Hellman, and elliptic curve Diffie-Hellman will all become vulnerable, and that any traffic that the adversary has observed and stored, when they do get the quantum computer, they'll be able to defeat those key management algorithms, learn the key, and decrypt them. The proposal here is in the near term, we can mix in a pre-shared key to a key derivation function, and that means that the attacker will have to also get a hold of that pre-shared key in addition to getting a hold of a quantum computer. In the long term, we want to use the algorithms that are quantum resistant, such as the ones from the that win the NIST competition. We don't know which ones those will be, so we can't do anything yet with those. Next slide. So the draft defines two quantum resistant ways to establish keys. In both cases, the PSK has to be distributed to the sender and all of the recipients by out of band. It can't use, obviously, RSA, Diffie-Hellman, or ECDSA to distribute the PSK, or that would just be another message the attacker needed to get. And then the two techniques are to basically use key transport as in something like RSA, and then mix the PSK with it, or key agreement, something like elliptic curve Diffie-Hellman or traditional Diffie-Hellman, and again, mix the PSK with it. Next slide. So this slide provides just an overview of what I just said, except that it points out a few more steps and that a key derivation function will be used to do that mixing. Next slide. Again, I'm hoping for review and comment. Next slide. And the ask is, again, adoption, and again, Tim will make the consensus call. Please do review and comment.
All right. So I actually thought that being able to see where people think was actually kind of useful. So again, how many people have read this particular document? Oh, wait, we have a couple. There's some comments. Let's do some comments first.
Okay, go ahead.
Oh, yeah. Thank you. Here's Guilin from Huawei. So personally, I like this this draft or this topic. I have no time yet to read the document, but I would like to read it later. Yeah, my question is this one. So you mentioned something like the strong PS key. So what does it mean for strong? Do you have some particular definition,
right.
especially from an academic paper or something? Yeah,
sure.
please.
So strong means that you're, it's got to be non-predictable. That's really the most important thing, and it's got to be long enough. So it needs to be at least as long as the key that will be used to encrypt the traffic. So look, those are the two things. And I don't know that I said that in the document, but I certainly can. And then who you distribute it to, you certainly don't want to go through a significant distribution ahead of every, say, S-MIME message. That would drive you crazy. But I could imagine enterprises distributing a key to all of the clients in that particular enterprise, so all of their traffic was safe as long as that key didn't leak outside the group. The more sensitive it is, the smaller the group you want to be. So, you got to measure that in terms of deciding the PSK, but the mechanism gets to remain the same. The only thing you're sending in the message is an identifier about which PSK you used. Okay?
Yeah, thank you. So second one is that you mentioned there is two particular methods have been specified in this document. So I would like to know, so is there any source about where these two methods is imported? Also according to some research results or just proposed newly?
Which tools are you referring to?
Two methods. You specify two methods to define like how to get the PSK or something. Probably you can show your slides.
No, okay. You back up. There's two mechanisms.
Yeah. Two mechanisms.
Okay.
That's right.
That's good.
Yes, I saw.
So there are key transport and key agreement. Key transport is the cryptographer's term for RSA style key management, where I make up a key and encrypt it in your public and send you the encrypted one, and you decrypt it with your private. And key agreement is more like Diffie-Hellman style, where I send you my public, you send me your public, I use my private and your public, and you use your private and my public, and we derive the same key.
I see. So both of the two mechanisms are actually still based on traditional public key, right?
And then you
In
take
your
that
specification.
result and mix it with the PSK. The only thing that's unique here is the mix it with the PSK. In other words, use the traditional stuff, then armor it by mixing it with the PSK using a key derivation function.
Okay. Yeah. Thank you.
All right.
Hi, Jonathan Hamill from CSC. I have a question whether you're aware of any other extensions to CMS that use this other recipient info fields, or is this
Yes.
the first one?
No, there's others.
Oh, there is. Okay.
Okay, Sean Leonard. So I understand the premise of why this works, of course, but given that it's also acknowledged that this is a stopgap measure compared to strong quantum resistant functions, I guess I would question whether it's time right now for us to adopt this as, number one, as a working group item yet, because it might be a little premature. And then second, whether this should be on standards track or a different categories such as informational.
Okay. So I would argue it's not premature. The whole point is to get something out there that would predict today's traffic while we're figuring out what a quantum resistant algorithm is. And we don't have that answer yet. So this is like the only thing we can do.
Valery Smyslov, Valery's Plus. I want to talk that there is a similar work in IPsec group, and the draft is currently in last call. And I just want to say it uses the same technique, mixing pressured key, but in our calls, as long with Scott Fleur and David Magru and Panos Kampanakis. Well, this particular pressured key is called post-quantum pressured key, a special term. It's probably a good way to consider the same terminology across the different drafts that use the same technique. So you could probably consider changing it to this name to be more explicit that this pressured key is used to defend against quantum computers.
I'll take a look at the IPsec-ME document and see if the terminology directly transfers. If it does, I'll certainly adopt it.
Thank you.
I'm just going to mention that this is a charter item, and it's a charter item at a standards track. So, of course, the working group could decide that they don't like that, but they just theoretically decided they did like it about 10 minutes ago. So,
5 days ago.
Exactly. Yeah. So yeah. Also, since I'm up here, I'm pleased to announce that Ben cleared his discuss. So I will start getting on through the document.
Yahoo! Jim's buying at the bar.
All right. So we had a few more comments on that one. So I think we're going to go again with option A. You think the draft looks more or less the way it needs to. Option B is you have some concerns about whether it should be informational or whether there's other work to do. So let's go with that right now. So option A. All right. And then option B. Very good. Thank you. Yeah. Yeah. Go to the mic. Every question deserves a mic.
Max Palak, Cable Labs. Does the option A include adoption of
Yes,
the
that's what
document?
his real question was. Adoption, not ready for
Okay, because it was not cut out. Okay, thank you.
Just a quick question. Is this in any way affected by the NIST's call for quantum resistant cryptography?
No.
No.
I mean, except that it'll be obsolete once we have such algorithms.
Because the submission ended last year in December, and it's supposed to be ready by 2024.
Yeah.
So is this
So if they're on schedule, we have a good 5 years to wait, right?
They're given it. And also, you have to understand, even if they finish at that point, then we have to start standardizing those algorithms in our protocols. Or actually, like in IPsec-ME, we already started. We have the this quantum resistant, as we call it. This is not protected against quantum; it's just resistant to that using this post-quantum shared key or something like that, PPK. So that's the stopgap, and then we have already started making the protocol that if we have protocol that will be protected against quantum computers, then we might have infrastructure which is ready for it when they publish the document, publish the actually algorithms that are usable. And in that case, we also actually still want to keep the old stuff there. We actually do both. We do both the traditional and the post-quantum calculation, because there's so much. The post-quantum stuff is so new that we want to make sure that we actually don't make it weaker by just adding that, or taking out the old one and adding new stuff that is completely broken would be bad.
So I would also observe that when Steve Bellovan and I were security ADs, we started this initiative to transition from SHA-1 to SHA-256. We thought, wow, we figured we'd be happy at 5 years if we were seeing, SHA-1 gone in 5 years.
Thomas Eckert.
Enough said.
Yeah. Yeah, I think the time frame looks like it's useful, but the problem that I have is rather figuring out where all the additional hula hoop that you need to do to have the out of band channel for the PS. Right. That's I'm not sure who could help to make a judgment call whether there sufficient good examples where this hula hoop is worth it, because that would be for me the criteria to say, yeah, sure, let's do it.
So I'll steal an example from Tanya Ling, where she said, if your grandchild was born this year, how long do you want the health records of that child protected?
All right, let's move on to the next one.
Okay. So this one is also in the new recharter. This is for an informational document. Next slide. So the idea is that if you have a root certificate and you add to it an extension that says, I have a hash of the next public key that will replace the one that is in the certificate, then you publish that hash value as part of the certificate. If you ever see a future self-signed certificate that has a public key that hashes to that value, it is the replacement for the one that you have in hand. So it's just a rollover mechanism. Next slide. Basically, the idea is at the time you set the initial certificate up, you create the first key pair, and you include in it the hash of the next public key from the next key pair, and you publish this. And then again, when you want to move to that second key pair, you need to compute the third pair so that you can hash that public and put it in that certificate, and so on. Yes.
Is that assertion bounded by the lifetime of the first certificate? Huh?
Unless you renew, right? You can certainly do cert renewal.
No, I'm sorry, I meant the other way. I meant, so I've got a certificate, I got a root certificate with a hash in it that extends till today. And then tomorrow, and then for some reason I don't get any kind of renewal. And then tomorrow I get a thing that has the right pre-image. Am I supposed to accept that?
I would think so, but I can make either argument. But yeah, let's have that policy discussion.
I don't really know either. I mean, I can make either argument as well, and like that.
Because I mean, I think there's no known cryptographic attack that would make that a bad thing. The question would be, if this is expired, why didn't you get it out in time?
Well, yeah, I mean, the idea I would have in my head would be the same reason why we should certificate expiry this way, which is to say that, that I'm only supposed to treat it as valid for that period of time, and that perhaps in this whole thing has been revoked. I know, not really revoked, but effectively revoked. But I'm not getting updates for it.
Right. I don't know. That's a great point to discuss on the list.
Jim Shop. Yeah, that's basically, I think, the same issue I had, which is if the current key pair gets compromised, how much of a mess am I going to be in? can I really trust this new hash?
Yes, and here's the reasoning, I believe, is releasing the hash of the new public key early does not let the attacker even find the key pair to begin cryptanalysis yet. They do need the public key to even start, because they have to first find the key pair that map to the hash value, which is supposed to be impossible, and then they could begin the cryptanalysis.
No. I was going to grab the I was going to compromise the R1 key pair, issue a new R1 replacement, and go.
Issue a new self-signed. Sure. Okay. That's that ties to what Eric asked. If I can create another self-signed certificate using that same key pair, but you're going to put a different H2 in it, right? And that's the whole reason for enforcing the not before or not after that Eric was talking about.
But on Jim's comment, I mean, if it's broken,
what is it?
I would be more worried if it's stolen.
Sure.
But if it's broken, it's probably the next key is not trustworthy either. But
if they're stored the same HSM, et cetera, et cetera, et cetera.
So, but on the first comment, I think that, and that's maybe something that is out of scope, but the certificate is not trusted to vouch anything about itself. I mean, that's the basic concept. So all the information about how and for what you trust the root key is out of band policy, including, I would suggest, the validity time. So I think that whole thing should be out of scope, what the validity time you actually have in a root certificate, because it's supposed to be when you say you trust it, you also say for what time you trust it. And that is decision process that is not taken from the certificate itself.
So you're arguing that this is only a mechanism for earlier rollover?
Yeah, I argue that should be a non-issue.
Okay.
Yes, similar to Stefan's point, back in the days when I was doing revocation, whatever, folk pointed out that you don't do status checking for root certificates, and
I'm aware of that.
They're special in many ways.
Yep.
And really all that a self-signed certificate is a notational convenience. So they're not really part of the same trust thing. So I think that we're on solid ground answering Eric's
okay.
Yeah, actually, I think quite a lot of those self-signed certificates we trust are still actually signed by MD5 because they're very old. Not anymore. I think most of last time, a couple of years back, when I check out my Mozilla roots, and most of them are MD5.
Okay. Let's not have that argument here.
But the question I have here is, what is really the what you are trying to gain from it? Because I mean, to be able to update the trust anchor, it's as I said, it comes out of band. Are you really thinking about, okay, if somebody ever gives you any certificate anywhere somehow during the negotiation or TLS or something like that, you happen to get a certificate that has a hash that matches any of your trust anchors, you are going to be accept that as a trust anchor?
Yeah, so this idea is actually way more than 20 years old. Okay.
Yeah, but I think it actually would be very scary about that.
But I think that there are systems where this makes sense. The first one that I'm aware of that used it was the set specification from MasterCard and Visa. They used a different syntax, but the same exact idea. And where in that system, there was one root and only one root. And the idea is if you needed to roll it, this was the mechanism that allowed you to do so.
And it automatically would take, if you ever see, or was there some out-of-band mechanism that tells us, oh, by the way, now I'm going to update my, trust anchor. So here is the new trust anchor. And yes, you can verify that the previous out-of-band thing had the same hash of that, which actually would mean that it doesn't have to be stored into the CA certificate at all. It needs to be stored along with the CA certificate. Then, okay, this is the hash of the next certificate.
They did not, as far as I recall, but it's been a while since I've looked through those specs.
Hi, Rich Sauls. Yeah, the most useful thing I think for this stuff is to be able to automatically update trust stores. Right now, people, they get it from the Mozilla Dev program or whatever it is.
Absolutely.
And it would be nice if CAs could then, they might have, the trust stores might have issues saying, I've trusted you now, and now that there's a provable chain, I'm not sure they want to make that guarantee to trust forever, but the ability to automate it, as we learned from Let's Encrypt, automation is good.
Is helpful. Yeah, exactly.
Yeah, Max Balakibbles. I think one of the points that, maybe is useful to raise is that, yes, the self-signed certificate in this case is a transfer mechanism for the key, not much more than that. And that having supposedly, if you get this key in a trust way, this is a good way to build a chain of trust. Even if the original key is compromised at this point, if you receive the key in a trust manner, then this allows you to trust the next one, and nobody can really influence that process. So this is very useful.
I could probably improve the words there, but yes, I agree with that summary.
I could be wrong, but I think there might be a better solution. That is to include
Write a draft.
Sorry. I will. Sorry. But so what if you instead included a hash of a very, very secure key that can be used to verify the next public key? Two advantages. One is that you could have some ridiculously secure key that takes a long time to process, but once you do it, you only do it once to validate the next key in line. And if something happened and you want to change key size or anything because cryptographic research and everything changes, you can decide when the next key is issued, how long it's going to be, and what aspects it should be, or even algorithm changes.
So I would actually worry about that mechanism being DDoSed, right? Here's the new key. Haha. It's actually not, when you finish that long
that's
process.
another thing, of course.
Okay.
I didn't think this through, but just a thought.
I remember when Microsoft did the checking in the wrong order.
Yeah.
I bet you remember that too.
Hi, Eric Scrolla. This isn't to say that this is something one shouldn't do, but my understanding of the way the root programs work, at least Mozilla, is this we would not accept this certificate.
I agree.
Namely, we require, take the case of a subordinate, right, which is inherently verifiable. We require you to notify us when you change your own internal subordinates. Yep. So we wouldn't accept the certificate. We insist you give it to us, and we give it to the browser.
I understand that.
So, I'm not saying this is inherently a bad process. I'm just saying I don't think it would work for browsers.
Right.
Okay, Sean Leonard. So I guess I have a question. Wouldn't it be better, or consider the approach of, instead of adding a second key that you're going to use in the future, why not have a hash or information in the new root certificate that can be used to identify and constrain essentially the damage that's caused by the compromised or expired prior root certificate? Because you have to receive the new root certificate through a secure out-of-band mechanism. Now, I understand that
you don't.
The whole
No,
point
you
of this
don't.
is that so you don't have to.
That's right.
But what if the new key is compromised?
What if the new key is compromised? You're
Right.
screwed anyway.
Right, but that just makes it worse, I guess. Is the point.
No, it's a trust anchor. You got no revocation mechanism.
Right, but then
Yeah.
it could be used to.
You're screwed.
This is Daniel Kahn Gilmore. So, right. So this seems like you're expanding the attack surface, as you just said.
Yes.
Right? I'm also wondering if we're envisioning an automated update process here, how do you see that happening? Because it seems to me like if there is a runaway, if there's a runaway attack.
What do you mean by a runaway attack?
Well, if you're willing to accept automated updates here, why can't I push 1 million of these at you?
You could push 1 million potential certificates at me, and I would see that the public key didn't match the hash in the existing trust anchor, and discard them.
Okay, so So,
at the expense of one hash.
so okay, but I'm trying to figure out how this interacts with things like CT that we're using, and
I don't see CT interacting with the trust store.
So TT does definitely interact with the trust store. The logs currently only accept certificates that are signed by root certs.
Yes.
And as a
But
user,
don't themselves, but they don't, if I understand this right, but the root certs themselves aren't in.
but the log can't operate without knowing the root certs, right?
Completely agree.
Okay. So so someone's issued a certificate. And when I talk to the logs, I know what root certs the logs accept.
Mm-hmm.
So suddenly I receive a new certificate and it chains up to a root C I've never seen before, but it matches a thumbprint.
Mm-hmm. Then you got to start.
Then do I expect the log to have logged it, even though the log may not have logged it? So I don't expect the log to have logged it. So now if I'm requiring CT, do I accept the new cert or do I not accept the new cert? You don't accept the new cert. Okay, so these new.
Sounds like that's a security consideration. I need that.
Yeah.
Yeah, I don't see how that fits together. And then on top of that, it seems to me like once there's been one, like, it seems to me like you could end up publishing R4 and R5 and R6 in the event of a compromise. And it's and you end up
in the
with
event of a compromise.
Yeah.
You're in the same place.
Okay, I mean, so if what we're saying here is in the event of a compromise, everything is on fire, then all this is doing is expanding the scenarios in the event of a compromise, which seems like not a great thing.
But no, if you find that you're, Jim pointed out the flaws in earlier, but the point is if the R1 gets compromised and you stop using it and you start using R2, right? As soon as the certificate is seen with R2, the clients will stop accepting anything that changes to R1.
So R1 is automatically disabled by the
Correct.
publication of anything with R2.
That's right.
Okay. It's a different sort of foot gun, but I hadn't understood that.
All right. Otherwise, you're in this state where the compromise key is being used and the not compromise key is being used, and you're not getting anywhere. Anyway, that's the idea.
Yeah, Rich Sauls. So it's a foot gun only if somebody can generate a valid key pair from just a hash and make it hash to the same value, right? So if we have people who can look at a SHA-2 hash and generate arbitrary content, then we have bigger problems than just this.
Yeah.
The other thing is I think this is useful. It doesn't address all of the cert lifecycle key distribution mechanisms.
That's right.
However, as we're moving towards more things that are on the net and things that want to do secure conversations, being able to automate updates of those things securely and give them a chain of custody from the thing they got from their manufacturer, that seems really, really, really worthwhile.
Thank you.
Queen Dan, would it be useful instead of signing the public key alone, you also, hashing the public key alone, you hash also the OID of the next algorithm you will use to sign the next certificate. For example, if you do, I say now, next time you do ECDSA, for example, then you hash the OIDs of ECDSA and the public key together. So in that case, you can make changes fairly more flexible.
So you're saying this would allow algorithm role as well as key role?
Yes.
Okay.
Maybe post-quantum role.
I'll think about that.
Oh,
I think we're in pretty good shape on time.
Guilin from Huawei again. So I have two questions. The first one is that from here, I think like the second generation root key and the initial one and the third one, basically they are separate, they are independent, but just one are supposed to replace the other one. That's right. Okay, thank you. Second one is that I'm concerned a little bit about the security because I'm not very clear of I'm not very familiar with the real procedure to issue certificate or something like this one. So one scenario I'm just imagining is this one. So I think when you will use the private key of the root key, or just you use the root key to issue certificate, we must very be careful if we use this scheme. Otherwise, if we use some automation system to check the certificate, in some case, maybe some guy or some bad guy, they may ask the CA to issue a certificate, which is actually, he may try to replace the future root key. Like now, maybe we have the root key R3. So one bad guy may just try to generate the root key 4 and ask the CA to issue a certificate for him. Yeah, looks like just for a customer, but later he can claim, or other users may explain this certificate as the future root key. So
Well,
this depends whether
there's two issues with what you just
the CA
suggested.
will check the content.
There's two issues with what you
Yeah.
suggested. One is finding the key pair that matches any hash is itself, we believe, computationally infeasible. Second, a certificate that is not self-signed should just be rejected as a potential trust anchor out of hand. Yep.
Let me say how to say that.
Mm-hmm.
So self-signed certificate still means okay. So what I mean is that so at least the root key server must need to guarantee when he would like to issue some certificate, he must need to check the corresponding public key is not it's self-public key. This is my point.
That in the
Yeah.
case of going to the second certificate in this chain, that the certificate itself is signed with R2.
All right.
Yeah,
and-
you said
and-
it for R2, yes, I know that one.
Yeah, if I can just break in here a second, I'm going to cut the line after the current line that we have, so we can discuss it further out on the list, but just the three of you are the last three.
Max Pala Cable Labs. One question for you. You mentioned that if you start seeing the new certificate used, you have to stop trusting the old one. But there are many possible reasons why you start seeing the new trust anchor before the other one is expired. When I want to keep continuity across many different devices, doesn't mean that the the key is compromised. I just want to roll out the next one. So
If you're going to just roll out the next one, yeah, I was going to say I wouldn't do it this way.
no, but I want to
Because
be,
you would want to extend the crypto period, move the, I mean, if you're rolling the next one out for all the reasons Eric already explained, we're not going to push the end date out. And maybe that's a discussion. Yeah, I do see this.
Okay, so given that, would it be a useful thing to say? I'm not clear about why this would be a bad usage of I want to pre-announce my next key, even in case it's not a disastrous event. However, have you considered maybe having a scope of that? So, for example, this hash for the next key is the key that I will use in case of a disaster, and this other key would be in case of.
So I'm going to put many of these in there now.
Yes.
Yeah.
With different scopes.
I'm reluctant, but convince me on the mail list.
Yeah, as Tadahiko from Second, it seems like this mechanism provides some integrity or equality of first and second like certificate, issuer of first and second certificate. But like then if the something like organization information are same like same for two certificate, you can like revoke first certificate or something. But at the same time, if you, I think you can use this mechanism for delegation. For example, if like holder of root trust anchor change or something, the first trust anchor can like use that hash key to second like certificate. Or I was saying was like this like functionality of this mechanism can very change like according to the how you put the data into those certificates.
I'm not sure I'm
okay,
following.
okay,
I'm trying
okay.
really hard, but I'm not getting what concern you have.
Oh, okay. I'm talking later. Yeah. Well, in any case.
Please write it down.
Yeah.
Well, this won't facilitate changing those things. I can't. This is a rolling the key mechanism, not rolling the name mechanism. We could say something about making sure other fields are the same, but I really didn't think about that.
Nope. All right. I think that's a fascinating discussion, and I think there's lots of good stuff to discuss on the list. One thing that I would suggest personally that I got out of this is I think the best way to think about it is under a normal rollover situation, somebody gives you a new key and root certificate, and you have no information to other than out of band stuff in order to evaluate whether it's the correct one or not. This is essentially bit commitment, where somebody has said, my next key will have this hash, and I'm going to store it with security procedures that are above and beyond what I'm using for my current key. And so if you see it showing up later on, you may use additional mechanisms in order to determine whether you can trust it or not, including asking through some mechanism whether the original was compromised or not, and whether you should just exit stage left. But the fact that the hash matches gives you some useful information to use in your trust decision. All right, so shall we adopt this as a good starting point for the next, for the rest of the discussion? I guess that's option A, and then option B is the building is on fire. So anyone, people who want to start, go ahead. Well, why don't we make that a third option? All right, so option A is we start with this and we go with it. Option B is now let me see if I can state this correctly. Option B is you like this, but you think there's a better answer that could be written up instead. Is that what you want? Okay. And then option C is you're not interested, or we should go do something else.
Option B makes no sense. Basically, adopt this or don't. If somebody has a better idea, then they bring it a better idea, and then we scrap this vote afterwards.
That's yeah. Yes, I'm convinced. It's A or B. All right. So A is adopt. B is do not adopt. So who's for option A? Okay. And option B? All right. Sounds like A to me, although not clearly, not by a lot. So, yeah, I guess that's right. To be confirmed on the list.
So Yo, are you remote? If so, come to the mic, please.
Yeah, I'm remote.
Yeah.
Hi, so I'm Javier. I'm remote this time. This draft, well, not this presentation, but this draft was presented at Sec Dispatch last time, and they told us to go to LAMP, so here we are. Next slide. Okay, so what is this draft about? It's called Star Certificate Short-Term Auto-Renewed Certificates. Now, both of these properties do describe star certificates, but neither short-term nor auto-renewed is the point. The point is that there is no revocation information. So short-term is what we have to do to make up for lacking the ability to revoke, and automatic reissue is what we do to allow us to overcome the operational challenge of using short-term certificates. The draft is intended to list the operational and security considerations for deploying an environment with star certificates. And the intent is for this to become an BCP. It's not standards track. It could be informational or better yet, BCP. So next slide. Okay, I'm going to run through two examples. I'm going to run pretty quickly through them because neither IPsec nor storage is the point of this discussion. So the first example is an IPsec VPN. So you got your medium-sized company, they have a head office, and it has its data center, and they've got 2 gateways for high availability in case one of them breaks down. There's also a backup facility that has its own 2 VPN gateways. You've got your R&D centers all over the world, and they've got several networks inside them, and again, VPN gateway. Then there are the regional sales offices and the smaller country, or in the case of the United States, usually a state sales office. Each one of them has between 5 and 30 people, and of course, yet another VPN gateway. Then you got a bunch of people who work from home. And for some reason, a lot of companies prefer not to give them software VPN clients, but rather give them small CPEs. Some good operational reasons for that. And then there are the people who travel around and then they have to use some sort of software VPN client. Maybe it's installed on their phones or on company-provided laptops or on their own laptops. Either way, we're getting hundreds, maybe thousands of clients, of gateways and clients, and all of them have to be authenticated. So next slide. So the challenges we face when deploying such a company-wide VPN is, well, we would like to stop intruders from connecting to our VPN and seeing our data. We want to prevent rogue gateways or clients from impersonating one another and getting the wrong kind of data. And we want to allow IPsec traffic from any gateway only if the source addresses of the traffic belong to the network it is protecting. Well, sort of an anti-spoofing thing. Now, all of these are good features and we can implement all of them, but all of them require authentication. So let's run to the second example. Next slide. Yeah, that's old job and new job. So software-defined storage, it's pretty much the same thing that used to be called storage area networks. And so you got your data servers. They're servers that have a lot of disk space, 5 to 100 terabytes each. And this data is either mirrored or it's partial, or it uses some kind of parity scheme. And there's anywhere from 1 to 100 data clients. These are application servers, web servers, whatever, that use the data. And they have some kind of driver installed. And these may be co-located with the data servers or not. That's the difference between converged software-defined storage and non-converged. And we define virtual volumes, and they are mounted on the data clients. And they're using some kind of protocol to read and write data from the data servers. And then we have this controller. The controller, of course, it's replicated like everything else. It's really running the whole thing. So if I say I need a new volume, a new 5 terabyte volume, it allocates the space, say 1 megabyte on data server number 1, 2 megabyte on data server number 2, and of course, different data servers hold the RAID copies. And mounting a volume on a data client means sending it a mapping, telling them where all the different megabytes of a particular volume are. And so the controller manages everything, balancing, recovery, whatever. So next slide. The kind of security challenges you have with such a setup is there are lots of things that you want to prevent. You don't want hosts that are not data clients to access your data servers and either read your data or overwrite it. And you don't want real data clients to access volumes that you didn't want them to, didn't mount on them. And you don't want data clients that have read-only access to write on the data. And you don't want an attacker to be able to impersonate the controller and then move everything wherever it wants to, or data servers, which allow them to either read, modify, or fake the data. So these are all good features. These are all features that we can implement, but all of these require that we authenticate everyone that participates in such a storage-defined storage, software-defined storage setup. So, for example, next slide. So this authentication that I mentioned, you can do the authentication using pairwise shared secrets. Anytime you start designing something like that with hundreds of nodes, you end up saying, no, I'm going to use certificates instead because PKI works. So where can I get certificates? Well, I can think of 3 sources for certificates. One is the global web PKI, your Komodo, your DigiCert, and they're nice, they work, and they're very professional, but they're very much geared for the web and a bit for email. They're mostly for the web. That's why they're called the web PKI. So the other source you can get is some kind of corporate CA. This could be a Microsoft Active Directory or several other things that are either bundled with an LDAP. You can even use your own XCA or whatever. But we find as vendors that this meets a lot of resistance because the people running the LDAP server and the internal and the corporate CA are not the same people who are running the storage or the same people who are running the networking and the VPN. And you sometimes need weird names for your servers or for your VPN gateways, and they don't fit with the naming scheme in whatever company. It's really difficult to use the corporate CA. You get this with a few customers, but most of them don't really want that. So the third option is to roll your own. And rolling your own really is a lot of times just Python scripts running OpenSSL commands. But it works, and then you can use whatever stupid naming conventions you want for your product. So it's very easy for a vendor to include their own CA with the product. So next slide. So the problem with rolling your own is that you really don't want to deal with revocation. Revocation is complex. Revocation is hard. And it adds a bunch of failure modes, and you have to deal with those failure modes with your Python scripts running OpenSSL. And revocation also takes time. So from the time that I figured out that my key is compromised or my server is compromised or I'm throwing away the server until the relying parties know about it and are going to reject the certificate, this takes a long time. This is at least hours and usually measured in days. Why? Because of the process that it takes and because of caching. This is really hard. And the other thing is that revocation slows down connection establishment because you have to go and check. And it's really hard these days to explain why issuing blob 1 and then issuing blob 2 to say that to the relying party that blob 1 is still valid, that doesn't really make sense, especially when issuing blob 1 and blob 2 requires same effort. In the old days, yeah, issuing a certificate was hard and was manual process, whereas issuing CRLs or OCSP responses was automatic. Now they're both automatic. So why do we need both? Next slide. Okay, so what alternative are we proposing? And the alternative is not to issue new certificates, and to stop the renewal. So to get equivalent security properties, we propose to make the lifetime of a certificate short. How short? Short enough that we get the same kind of time between stopping issuing until the certificate just expires, as we had with the issuing revocation. So short could be days, could be hours. It all depends on how accurate the system clock is. Yeah, use NTP, people. So to deal with the administrative nightmare of issuing hundreds of certificates every day, we really have to do it automatically. There's no way this can be done manually, especially when there's hundreds of data server or hundreds of VPN gateways that all look the same. So next slide. So this draft, admittedly, this draft requires work. These are the use cases have to be expanded, and pretty much through there, every kind of issue, whether security or operational, that I could think of. There probably are others. There are probably pitfalls besides the obvious time thing. This requires a lot of work, and we hope that this work can be done in this working group. So the next slide just has some anticipated questions, but feel free to run up to the mic and come up with your own. So next slide. So these are the questions that I anticipate. And so is this for the web? And my initial instinct is to say no. I mean, I don't know. Maybe this is good for the web, but for the web, we already have Acme writing documents, especially for the web. There's the CA browser forum. In making rules for issuing certificates for the web, there are lots of places to do that, and this draft in LAMPS is not the place for that. If what we come up with is good for the web, so much the better, but this is not the use case that is driving this draft. So the other question is, there was a proposal that we need some extension to say this is a star certificate, we have no revocation information, rather than just not including the extensions that say this is a CRL, this is an OCSP response. I don't think so, but if the group wants it, it's fine. But I want this document to remain a BCP or informational and not a standard string. So if you want some new extension that says with an OID that says no revocation for this certificate, let's do it in a really small, different draft. And the third thing is, well, do we really need to skip revocation now that we have TLS 1.3 and we can use OCSP stapling on both the client and the server side? And I think we still need no revocation certificates. And the reason is that it does solve the issue that we used to have that, well, assuming TLS 1.3 is clears off 48. It does solve the issue that we can't do mutual authentication with OCSP stapling, but it does not solve the complexity. It does not solve the requirement to have an always-on revocation server. It reduces some of the failure modes, but it does not eliminate them entirely. So I think there's still great value in doing a simplified PKI that does not include checking revocation. Okay, so that's the last slide, and yeah.
Okay, Stefan?
Yeah, one of my questions were up there, the other not. So I tried before, and I will try again, and if I fail now, will forever sit down and shut my mouth. But from the beginning, I think...
Forever?
Yeah, well, I really think it's a really bad idea to call this short-term certificates. I really like non-revocation certificates. I think it's very important to have non-revocation certificates. I would like to get rid of short-term because short-term is only one usage example. And I really want to use this for solutions or situations where the certificate is not necessarily short-lived. And the use case I have that is important is when we use a key, we generate the key and we use it once. And we are very sure that we're using it for the right thing, and we issue the certificate. The certificate is valid for a long time, but we throw away and destroy the key immediately after using it. We have signature systems working this way, and we need the same solution there. There is no reason to have revocation for that certificate because I have so much control over the use of that private key in that one instance before it's destroyed. So two different situations that needs the same solution. I'm going to have a hell of a lot of problems selling this if it's called short-term, because people believe acronyms and names and say, no, okay, you're not use that because that's short-term. Well, it's exactly the same usage. And also, I do think that we need an extension or to use an extension. And ideally, I think that we need to deal with situations where old installations, they just require a CRL. So there could be a link in the certificate saying, here is an empty CRL for those who cannot understand this. And all the new installations or new software that can deal with this could read the extension and say, by the way, don't bother check the CRL because it's empty anyway. There's no revocation of the certificate. And that way, both the old software and new installations and software could use the same certificate and work from day one.
Right. So I tend to agree about the naming, except that there are other documents that describe such certificates going around the IETF, and they are using the name STAR. There's one in Acme. There's another potential one that may come to Acme. So I'm fine if the group wants to bike shed and come up with another name, but for now I use the name that is used throughout the IETF. As for the extension, okay, I get the, okay, I understand that. Again, people want that. That's okay. And regarding the second use case, I think it's questionable whether we can or whether we would like to have a single document covering such very different use cases. Again, this is something for the working group to decide, but yeah, I can see it going both ways.
I just think that the document should not prefer any use case. It's just offer a solution, and that's a policy outside of the document that decides whether the document is to be used or not.
Well, but what the document says is that a good thing to do here is to issue a new certificate every 4 days, and that doesn't really fit your use case.
Yes, exactly. And all of that kind of wording I would like to remove from this document and not do policy in this document. But you want to do it clearly, but I mean, that's just my opinion. So what content would the document have if we remove that part? It's fine to not have a revocation, and that's it? Well, I think that you want to have a policy document saying when it's good to have a document without revocation. I think I would like to have a technical solution that can be used for different situations and policies, and I think maybe that's a difference.
Mm-hmm.
Thomas Eckert, co-author on the document, and so coming from the automation of the enrollment system that we have in Anima that we described in there, the key aspect for me is simply the ability to express as a permitted, policy within the PKI definition that we have, that registration authority can basically leverage expired certificates purely for the purpose of renewing them, right? Because that in the whole automated system is the biggest risk that happens, that creates discontinuity, right? That basically you're working with short-lived certificates, and then basically you don't have the ongoing connectivity required to continuously renew them. And in that case, you may want to renew later. And the best interpretation of all the Anima co-authors on that enrollment scheme is that the PKI documents that we have does not currently explicitly permit that. It's not clear if it explicitly denies it, but so far I think the systems I've seen would not permit it. And so simply for the purpose of renewing the keys or rekeying, whatever the renewal operation is, also permit the expired certificates, right? Because when we go back and you can check out all the complexity that we did for initial enrollment, all the trust stuff, that's a much more complex operation, which is why, I'd love to have that better leniency explicitly defined as part of, the PKI procedures.
Hi, Yov. Just to Torlis, I think I'm Sean Turner. The CP that defines how you use your CA can allow you to use expired certificates. You can explicitly put that in there. Some do, some don't. I know that there are some that do support allowing you to renew.
Right. So I wasn't talking about software. I was talking about the, what we think the current, Bibles in the RFCs say. If they say it's permitted, I'm fine. Then I would basically just inherit it.
So I think it's RFC 3647 is the CP and how to write that. So you can write whatever you want in there and say, use an expired cert. You can use it for 1 day expiry, none, whatever. It gets a little interesting then because then you have to put a CP OID in your cert, and there's legs there. Just let you know. Yov, I liked your presentation a lot more than I liked the draft. So I agree that I like that it needs work. I was like, oh, that's totally, yeah, it kind of makes sense, I guess. But in reading the draft, I think that there were some things that were factually incorrect, and I think it would be way too early to adopt this draft at this point. For example, it says things like the certificate discussed in this document have neither a CRL-DP extension nor an OCSP authority info access extension. In other words, such a certificate cannot be revoked. That means all version 1 certificates can't be issued, and any version 3 certificate without those can't be revoked. And that's just factually incorrect. I thought that the rationale in section 2 was really funny. STAR has several advantages over OCSP stapling. It's like, the CA is issuing things so quickly, it can just not even keep track of the issued certs. Have you ever talked to an auditor? Like, hey, I used this cert for what? I didn't keep track of that. Good luck. There's a couple of other things, like I don't have to run an OCSP web server or whatever. I mean, yes, it is more complex, but it's not that hard. I mean, it's like putting up a web server, right? I mean, these are literally boxes that you start up and hit the button and off you run. I don't know. I think really what the rationale is, you don't want to waste the time to go get the CRL information. I think we should just be upfront about that. And that's really what it is. I'm not trying to back your way into the rationale. But like I said, I like the idea of short-lived certs, or I guess revocation-free was the term I tried to use last time to put a nice positive spin on it. But I think this draft is so maybe a little early to be adopted. Thanks.
Sean Leonard, I wanted to respond to one point here about the extension for no revocation information. So it turns out there already is a extension defined for this. It's called no rev avail, and it's in X509. Now, X509 only defines it for attribute certificates, not for public key certificates, probably for all the reasons that have been alluded to, in this discussion. But I did want to point out that it is there, and similar to what Sean Turner mentioned, if the objective is really revocation free, then that should be explicitly stated inside the certificate with that extension or a similar extension. And the behavior is predictable.
That extension is also in 3281.
So yes, the purpose is to have revocation free. I mean, I don't think anybody is really really wants to churn out new certificates every 2 days if they could help it. That's the price we're willing to pay for being revocation free.
So Max Bala, Cable Labs. I voiced my concerns about this proposal many times on the list. I don't think that you guys have done any attempt to actually address those concerns, and this really scares me because I think that you are underestimating the importance of these concerns. One of the things that I want to point out is that there's no way that you can demonstrate that short-lived certificate without revocation as equivalent security level of a system with revocation. Revocation happens for many reasons, not just for key compromise. Let's say your employees leave the company and you want to block the access right away, not waiting 7 days because your short-lived certificate cannot be revoked. So there's many reasons why I think this should be really, the scope should be clear, more clear. You say the scope is about this type of problems, but then you say it can be applied maybe in the web if it's good enough. I would say if you want to publish a BCP, you have to to clear the scope, this is not for web, this is for this type of use cases, contrary to to what you said before. But and I voice also what Sean Turner said. There are many other implications. So I would really like. I don't think it's ready to be adopted. I have not seen any updates on this for many months. So I think that until we see an update and improvement, it should not be adopted as as in its current state. Maybe for the next iteration.
Turkey, I have a response to that. If some employees leave the company, you want to clear them out immediately. Yes, that means you want to clear all their existing connections immediately. Revoking his certificates won't do that in most of the cases. Even if you revoke it, for example, let's say IPsec, which I know, you have an IPsec connection to there. Even if you revoke his certificate, nothing happens in IPsec connection. Your SSH connection that you have, you revoke the certificate that was you created that, nothing happens to that SSH connection. You need to go and remove his credentials into the system. You go in the SSH, you go and remove his password and kick him out from the system. Even actually you remove his, etc password entry, that doesn't kick him out of the system. You just need to go and kill his SSH connection. Revoking credentials don't break the existing connections usually. So that's why I think, yes, even if you revoke the certificate, and of course, CRLs are usually 1 hour or 2 hours and so on, he can still do, huge lot of damage to, removing everything in the last 2 hours. You want to make sure that he gets, kicked out immediately, and you don't use revocation for that.
Hello, Philhan Baker. Yeah, if you're going to rename them, I'd call them implicit status certificates, or try and work that so you don't need to change your acronym. Twist star into saying that. This does come up quite regularly in web world, and the reason that it turns up on the web PKI is that once you've got to OCSP stapling, well, your OCSP staple is de facto the same as a certificate for the party that's stapling it. And so when you do all the math and so on, why have two things when you could have one? So it does keep coming up, and the main reason that the web hasn't gone that way is that there's folk who don't believe that PKI requires revocation. They're wrong.
So one, just a reply to that, you're totally true. You need to have good security control in your company. However, revoking prevents the user to actually get in using these credentials. So I'm not saying this was just an example. There are many other that one can come up with. I just think that making statements like the same security level is probably misleading. You cannot have the same security guarantees. I made examples that have not been replied to in the main list. So if you have the way you can reply to that and demonstrate that those are the same level. If you do that, I'm happy to abide by that. But until I see any good argument around that, I don't think, and as I said, I think that the draft needs to be taken a look at a little more seriously.
Anyone else? Okay. So Yov has asked us to adopt this. Several have said it's not ready yet. I'd like to see if those are the outliers or not. So simple hum for adopt now or wait for improvements. If you'd like to adopt now, please hum. If you'd like to wait for improvements, please hum. I would say the second was significantly louder. So Yov, we're not quite ready yet.
Okay.
Okay. Alexei, you're up. You gave up all open, my client was up.
So, yes, in this presentation, I was trying to insert pretty pictures of how broken existing mail clients are for this, but it didn't work during conversion. So you'll just have to trust me. I can tell you, you can try it for yourself. Right, so here we go again. I would like to protect message headers.
No, you should say still.
Still, again, still, yes. Yeah. Yes, so yes, pretty much. The intent of this presentation is, I don't want to discuss specific solution. It's more of a call for action, and hopefully we can have an idea which way we want to do this. So as far as I know, most SMIME implementations don't protect encrypt or sign message headers. Sometimes it's desirable to protect at least subject, date, sometimes maybe from and to and other header fields. So RFC 5751 and its replacement say specific tags to wrap in a message within content type message RFC 822 and include the headers you want to protect within it. So sort of copy the headers you want into the inner message. Next slide. So yeah, sorry, this didn't sort of fit on a single slide. So this is the outer header, and the subject can be fake subject or some dummy subject. So the outer headers. I'll teach you later, Russ. Then, so this is a multi-part sign as an example, and the first part will be on the second slide, contains the inner message. Next slide, please. Okay, well, nobody's perfect. So this is the inner message. So there is a wrapper, content type message RFC822, and then you include the inner headers together, with the rest of the message. So in theory, according to RFC, that should be header protection. In practice, you can guess. Okay. Well, yeah, there is one problem is, if you really want to include arbitrary nested messages at top level, you can construct some messages in MIME, and it's undistinguishable in this case. But the main problem is that, yeah, I don't know any other implementation than mine that actually does this. So I was trying to generate this message, and I was trying to see how they show up in various current clients like Thunderbird and iOS. And
so I don't know that they do it this way, but there is. I'm Sean Turner. So we've done this like 3 times, right? And it never seems to stick. Because I know that there was an ISC document that did like securing header fields.
Hold on. It's nice. Mentioned there. It's there. Don't just let me finish. Okay. Next slide. So yes, basically they show it as forwarded messages. And in many cases, it displays as at least extra set of headers, which is confusing to users. And in worst case, you see an icon on which you need to click to actually see the inner stuff. This is really ugly. I'm sorry the existing clients do that, but that's just the way it is. Right, 3 proposals so far. There is a memory hole proposal used by PGP people, and yes.
Memory hole is currently implemented in Enigmail and in K9 Mail, both of which use OpenPGP. That's correct.
Right. Then there is RFC 7508, which is independent stream experimental RFC, which says includes copy of header fields into special attributes that included in a signed or encrypted CMS. So again, they're sort of invisible to the readers that are compliant with S/MIME but don't recognize them. And the third approach will do nothing and really try to beat existing implementations, try to actually do what RFC says. A bit more details on this. Next slide, please. So this is my understanding of what memory hole does. Instead of wrapping everything in content type, message RFC 822, just copy headers with the rest with the content types like text plain or whatever, which is required to be there anyway.
That's what the really, really old Microsoft Mail program does.
You know,
So this is DKG. I can speak to more detail on memory hole if folks are interested. This is the core of what it does. There is an additional thing that it does to try to handle those clients that are capable of decryption but not capable of reading protected headers as well, to actually display things like subject there. But this is the core of it. That's right.
Yes. The advantages of this is that, again, most clients will just, the clients that don't support it, just ignore the extra header fields because they need to have header parser and accept arbitrary headers they don't recognize anyway. So, and when you display it, it will not show it as a forwarded message. It will just show you as a regular signed encrypted message. Next slide. Sorry, yes, I basically said the pros are, you know, it's sort of backward compatible, but we need to change the RFC. Next slide.
I can give you one additional con to this in the way that you framed it here, which is that if you, is that existing clients, if you don't do anything beyond the core here, will not be able to show you the protected subject line if the outer subject line has been stripped. So does that make sense?
Right. Or if it's different, it's not going to, it is going to show you outer.
If the outer subject line is encrypted message, and the protected subject line is dinner plans,
it will show you encrypted message.
It will say encrypted message with an old client. It will just say encrypted message.
Right.
So the memory hole approach is when you is that there is an advisor, there's basically an additional part added to the inside of the encrypted message, which is text RFC 822 headers, which contains those headers that are expected to be displayed by older mail user agents, so that you can see it like sort of in the body,
right?
And user agents that understand the memory hole approach are expected to suppress that part.
So okay.
That's just to clarify that that's beyond that part is considered advisory. You don't have to do that.
Right.
If you're talking to somebody else who already does memory hole, you don't need to include it. But that's the full piece of it.
Okay.
To avoid this additional con.
Thank you.
What is displayed in your inbox? Just encrypted message, or does it pull the protected one?
We're getting into mail user agent user interface flows, which is kind of awesome. I've always dreamed that the IETF might be willing to branch out into this. Depending on the mail user agent, if it is caching the clear text, it will show you the clear text of the subject line.
Thank you.
So again, I mean, the 7508, again, you need to change clients and you need to do, it's sort of backward compatible. You need to change clients to support it. But again, you need to change RFC. And do nothing, you know, it's sort of the reverse. The RFC stays the same, but we still haven't solved the problem. So we really need, you know, it requires more sort of marketing outreach and talking to people to fix stuff. Can we please fix this? I have my preferences, but it doesn't matter at this point, you know, what my personal preferences are. I just want this fixed.
this is DKG. We clearly need to fix this. We're 30 years in, and it is absolutely ridiculous. I would use stronger language if I wasn't speaking at the mic. The mail user agent that I'm working on, the patch series that I'm working on addresses both Alexa's proposal and the memory hole approach when it's interpreting messages. I don't know what to emit. I'm happy to emit either one. I don't particularly like the CMS encoded headers because that doesn't work for OpenPGP. The forwarded equals no suggestion that Alexi made and the memory hole suggestion both work for arbitrary MIME structure nesting, which works for RFC 3156 as well as the SMIME stuff. So I just want one way to emit. I'm happy to make my mail user agent process multiple ways of protection on return, but really to make this work and to make it work for the humans who actually use email, we do at some point need to start talking about what the user experience is supposed to be. Russ's question is right. What shows in the user agent and how do we manage that? That's beyond the scope of this, but we need this mechanism in order to be able to address that more fundamental question.
Right.
The memory hole approach may actually get you a bit farther than what you think today. The reason how come the old Microsoft Mail program did this was actually a bug in it. So in point of fact, it serialized the headers in before it encrypted it, and then it serialized the headers in again. And when it decrypted it and unserialized the headers, it serialized them back to the top level. So in point of fact, the encrypted versions overwrote the unencrypted versions. There may be other mail programs out
That's
there
awesome,
besides
but
that
I like
have
it.
that problem.
Can we all implement this bug, please?
So that I would guess that mail user agent doesn't deal with deeply nested multi-part structures. Well,
no, that was the era he's talking about was before mine.
Well,
No. All right.
So my suspicion. So as I've been implementing this stuff and trying to make sure that this works. Sorry, this is DKG again. The fact that we have gone ahead and have these like arbitrarily complicated MIME structures is a serious pain point. It's a pain point for implementers, and it's a pain point for users who cannot understand where the crypto in their message applies.
That's right.
So I mean, we saw this with eFail, right? I'm sort of surprised there hasn't been a presentation on eFail at this session because we should acknowledge this is a failure of this community for a long time. So we have to be very careful when we're specifying this that yes, when you're decrypting and then extracting headers from the message, there's only one particular point that is where the protected headers could be. Because if you pull out those headers from 2 stages down into the MIME structure, then you end up writing arbitrary stuff over the outside message when you do the decryption. And we need to be very clear about what that one point is.
Hi, Sean Turner. What DKG said when he got it the first time, I agree with the second part too, but still. Now that we've got SMIME version 4 out there, and the idea was we started this working group because people were actually going to go out and implement it. Can we not just contact the same set of people that wanted to do the authenticated envelope data and be like, can you do this too? I mean, if you're going to drop code to put in a new content type to do SMIME, this doesn't seem like there's that much of a leap to get to do a little bit more. And if you're fixing eFail stuff, like let's do that too. So it seems like, now maybe is the right time to try to reinvestigate this. And I don't care how you solve it, just do it.
I'd like to ask a follow-up question, Sean. Wait a minute.
Yes.
Okay, I'm not sure whether you were advocating pulling those documents back and adding this.
I don't think you need to pull the documents back to fix this. I think you can do it with an update document. It's the same, like, if we can do this and do this quickly, because there's only so many ways to do it, and hopefully we could actually decide fairly quickly.
That's true. I suspect we actually already have text and various forms to fix it. Any one of those 3 ways.
We've literally done 3 ways, and we could do a trade-off and like, okay, what are we going to do? And then like give everyone swords and see what happens.
Okay, blood. but you answered my question.
Okay. This is just, yes, arbitrary structures of MIME is going to be fun. And I don't know that we can always say that you have to take it from you can't take it from the second level down, because you end up with things like mail agents, which push everything down a level, and you may actually at that point end up with two multi-part encrypted pieces if things are really interesting.
There are also things like triple wrap,
Yes.
which I have, again.
I've written and published independently of the IETF. I'm happy to put it into an internet draft to put the useful and explicit description of what I call the cryptographic envelope, which is the series of contiguous cryptographic layers of MIME that have no non-cryptographic layers in between them, versus the cryptographic payload of a message. And it is actually fairly straightforward to specify where the headers come from if you are willing to force your MIME perception into this view that there is a cryptographic exterior envelope and a cryptographic, and then there's the payload. And yes, somewhere in the payload you might find some other crypto layers, and they are not going to affect the external headers of the message. If you adopt this conception, this simplification of MIME, and you force your mail user to work that way, then it's actually fairly easy to identify the location where you expect the protected headers to reside.
So there are
So
sort
wait a
of
minute, can
separate
you-
two related issues, and you're sort of talking about the second one, which is also nice to fix.
Yes.
I'm just trying to say that there are two, related but two separate issues.
Yes, but if you don't conceive of a cryptographic envelope, if you don't have that conception, then it becomes very difficult to identify where the protected headers should specifically exist. Because you could have, when you have a triple wrapped message, right? Now we're talking about potentially having headers that are pushed from the outside into layer 1, outside into layer 2, or outside into layer 3, and potentially in all three places. And you now get to decide which message you expose to the outside, and you get to decide how you expose to the user what cryptographic protections were associated with the particular header that you're looking at on a per header basis, which is a nightmare.
Yeah, that's bad. Could you send to the list a pointer to the document that's already written, just to save us? We can explore the idea, and you don't have to write a draft. That happens.
DKG will hate me for this, but another option on how to fix this is to define a new content type.
You're right.
Which solves the message because it takes it out of the MIME world. Okay, so we define a new content type which says, I'm a MIME message and I have protected headers.
Or new CMS type.
CMS content.
CMS content type.
You can also do a new MIME type, actually.
That would provide the same.
But sorry, I'm just creating more alternatives. That's probably not very helpful.
Do we care about this rendering on old clients? If we do, a novel MIME type or a novel CMS type is not going to work.
Help, right?
That's a very good point. I've made that argument in the past. Okay. So I think the question that we're faced with in the last 1 minute of the session is this something the working group would like to talk to the ADs about adding to the charter? Would like included in charter, do not want included in the charter. Those are two things we're going to hum on. Okay? Want to add it to the charter, hum now. Want to put Alexei off again, hum now.
Would you really like to hurt me?
Okay. Thanks for all your attention. Safe journeys home. After TLS, of course.
Yeah, but ultimately where would that take us?
I think it worked out. It worked out.
Yeah.
Yeah.
What? Blue sheets, could you bring them up?
We should maybe have a substantive technical discussion in a couple of weeks. If you have